Hello everyone. Welcome to SHR Trinity. In our previous video, we explored zero-shot prompting. Today, we advance to the next critical technique, chain-of-thought prompting. In this video, we will cover the foundational interview questions on chain-of-thought prompting, explaining how providing just a single example can drastically improve a model's accuracy and format adherence. Let's get started. Before we begin, if you're looking for practical, industry-oriented training in artificial intelligence and generative AI, SHR Trinity offers a comprehensive 30-hour training program. For complete course details, check the description below. Now let's begin today's interview session. We will now begin with the interview questions for chain-of-thought prompting, Part 5, Production Prompt Chaining and Multi-Step Systems. Question 1. What is prompt chaining and how does it decompose complex tasks into sequential LLM calls?
Prompt chaining is an architectural pattern where a complex task is broken down into a sequence of smaller, modular prompt steps. The output of one LLM call is validated, transformed, and passed as the input context to the next LLM call. Rather than asking a single prompt to perform intent classification, entity extraction, sentiment analysis, and summary generation all at once, prompt chaining assigns each subtask to a focused, dedicated prompt node. For example, chain step 1, extract key facts from email-chain step 2, classify intent-chain step 3, draft response based on facts-chain step 4, audit response for safety. A common mistake is creating monolithic God prompts that attempt to solve 10 complex subtasks in a single LLM call, leading to instruction drift and high failure rates. As an interview tip, explain prompt chaining using the Unix philosophy: build small, single-purpose nodes that chain together clean inputs and outputs.
Question 2. How does prompt chaining differ from single-prompt chain-of-thought prompting?
Chain of thought, CoT, occurs within a single LLM call where the model outputs reasoning tokens into its own generation buffer. Prompt chaining involves multiple programmatic LLM calls managed by external application code, Python. CoT relies on the model's internal self-attention across a single output stream. Prompt chaining allows external Python code to intervene between steps, parsing JSON, validating schemas, querying external databases, or routing conditionally. For example, CoT, single prompt generates reasoning and final answer. Prompt chaining, Step 1 calls LLM-Python validates JSON-Step 2 queries SQL database Step 3 calls LLM with SQL data. A common mistake is thinking prompt chaining is done inside the prompt text, rather than recognizing it as an application software architecture pattern. As an interview tip, highlight that prompt chaining allows code execution and external API integration between LLM steps.
Question 3. How do you manage state and pass intermediate outputs across chain nodes in a production workflow?
State across chain nodes is managed using centralized state objects, like Python data classes or Pydantic models, stateful context dictionaries, or framework state graphs, like LangGraph state channels. As execution flows through the chain, each node receives the current state object, appends or updates specific keys with its generated output, and passes the mutated state object forward to downstream nodes. For example, a Pydantic state class containing attributes, raw_user_query, extracted_entities, retrieved_docs, draft_answer, and final_approved_text. A common mistake is passing raw unparsed string dumps between chain nodes, causing context pollution and formatting errors in downstream steps. As an interview tip, advise using strongly typed Pydantic schemas for state passing to guarantee runtime type safety across nodes.
Question 4. What is error propagation in prompt chaining and how do you build validation gateways between steps?
Error propagation occurs when an incorrect output or hallucination from an early chain step is passed downstream, causing compounding failures in subsequent steps. Validation gateways prevent this by checking schemas and accuracy between steps. If Step 1 extracts an incorrect user ID, Step 2 queries the wrong account data, and Step 3 sends a bad email. Validation gateways use pedantic schema validation, regex filters, or LLM guardrails to intercept flawed outputs before passing them forward. For example, if step 1 JSON fails pedantic validation, the gateway catches the exception and triggers an automatic retry prompt. Fix this JSON syntax before proceeding to step 2. A common mistake is connecting prompt chain nodes directly without validation barriers, allowing single-point errors to corrupt the entire pipeline output. As an interview tip, mention the pattern, validate at every boundary, retry or fall back gracefully on validation failure.
Question 5. How do you handle conditional branching and routing in an automated prompt chain?
Conditional branching is handled by placing router nodes in the chain. A router node classifies input intent or evaluates step state, returning a decision label that determines which downstream branch is executed. Instead of executing a fixed linear sequence, step 1-step 2-step 3, a router node evaluates the state. If intent is billing, it routes to branch A, invoice chain. If intent is technical, it routes to branch B, troubleshooting chain. For example, router node classifies customer email into refund, tech support, general. If refund, route to refund handler node, else route to FAQ handler. A common mistake is building massive rigid linear chains when dynamic routing would execute shorter, specialized subchains faster and cheaper. As an interview tip, compare router nodes to control flow statements, if-else/switch, in traditional software development.
Question 6. What tools and frameworks, LangChain, LlamaIndex, LangGraph, are used to build production prompt chains?
Production prompt chains are built using orchestrators like LangGraph, stateful graph execution, LangChain expression language, LCEL, LlamaIndex workflows, or lightweight custom Python frameworks using async.io and Pydantic. LangGraph provides cyclic graph capabilities, built-in persistence, and human-in-the-loop approval features. Custom Python with async.io and instructor/outlines offers ultra-fast, lightweight, production-grade chaining without framework bloat. For example, using LangGraph to construct a stateful customer support graph with human review approval before sending final refund emails. A common mistake is overcomplicating simple two-step chains by adopting heavy framework abstractions when clean native Python functions are easier to maintain. As an interview tip, advise choosing frameworks based on complexity. Use native Python for simple linear chains. Use LangGraph for cyclic stateful workflows.
Question 7. How does parallel prompt chaining improve execution latency for multifaceted analysis tasks?
Parallel prompt chaining executes independent subtasks concurrently using async.io or multi-threading, merging their results in a subsequent aggregator node to reduce total end-to-end latency. If a task requires analyzing sentiment, extracting entities, and translating language, running them sequentially takes T1 plus T2 plus T3 seconds. Running them in parallel takes max T1, T2, T3 seconds. For example, executing 3 parallel LLM calls to evaluate a contract for legal risk, financial risk, and compliance risk simultaneously, then feeding all 3 reports into a final synthesizer node. A common mistake is running independent subtasks sequentially in a chain, causing unnecessary latency buildup for end users. As an interview tip, state the optimization rule. If step B does not depend on step A's output, execute them concurrently in parallel.
Question 8. How do you log, trace, and debug complex multi-step prompt chains using tools like Langsmith or Phoenix?
Multi-step prompt chains are debugged using LLM observability platforms, Langsmith, RI's Phoenix, OpenTelemetry, that capture full execution traces, step latencies, exact prompt inputs, completion outputs, and token costs per node. Debugging a 5-step chain without tracing is blind guessing. Observability tools record every node's exact payload, allowing engineers to pinpoint which specific node introduced a hallucination or caused high latency. For example, opening a Langsmith trace visualization to inspect why Step 3 received malformed JSON context from Step 2 during a failed production run. A common mistake is deploying complex prompt chains to production without tracing instrumentation, making root cause error diagnosis impossible. As an interview tip, emphasize observability as a production prerequisite. Never ship a multi-step prompt chain without OpenTelemetry tracing.
Question 9. How do you optimize latency and cost in a 5-step prompt chain using hybrid model routing?
Hybrid model routing optimizes cost and latency by routing simple intermediate steps, classification, extraction, to fast, inexpensive models, e.g. GPT-4o Mini or Claude Haiku, and reserving expensive models, GPT-4o, Claude Opus, for complex synthesis. In a 5-step chain, steps 1, 2, and 4 might be basic formatting and entity extraction. Running them on a micromodel saves 90% in token cost and latency. Only step 3, complex reasoning, requires a flagship model. For example, steps 1 and 2, extract and filter Claude 3.5 Haiku, 25 cents per M tokens. Step 3, strategic analysis Claude 3.5 Sonnet, $3 per M tokens. Step 4, format JSON GPT-4o Mini, 15 cents per M tokens. A common mistake is using top-tier flagship models for every single node in a 5-step prompt chain, leading to inflated operational expenses. As an interview tip, highlight model routing as the single most effective lever for reducing enterprise AI infrastructure costs.
Question 10. What is the overall architectural ROI of prompt chaining versus fine-tuning a single custom model?
Prompt chaining delivers modular flexibility, instant updatability, clear observability, and zero model training compute costs, making it far more cost-effective and agile than fine-tuning a monolithic custom model for multitask applications. Fine-tuning a single model to handle 5 distinct tasks requires massive dataset collection, GPU training runs, and risky retraining whenever business rules change. Prompt chaining allows updating a single node in minutes without touching the rest of the pipeline. For example, updating business compliance logic in step 4 of a prompt chain by editing 2 lines of prompt text, versus 3 weeks of fine-tuning dataset retraining. A common mistake is prematurely fine-tuning custom models for complex enterprise workflows before exhausting modular prompt chaining architectures. As an interview tip, conclude technical architectural discussions by highlighting modular maintainability, developer speed, and lower total cost of ownership.
Excellent. You've completed Chain of Thought Prompting, Part 5, Production Prompt Chaining and Multi-Step Systems. In the next video, we'll dive deeper into using one-shot prompting to enforce strict JSON and XML outputs for API integrations. If you found this video helpful, please like, share, subscribe to SHR Trinity, and press the notification bell so you never miss our upcoming AI interview preparation videos. Thank you for watching. See you in the next video.